Hey, everybody, and welcome back for our weekly deep dive. A special shout out to anyone joining us from the Science Telegram channel.
Yeah, welcome.
So for this deep dive, you guys sent us a really interesting collection of sources about all kinds of different, well, scientific discoveries.
Yeah, from astrophysics to biology, even some stuff on quantum physics and potential new energy sources. A really good mix.
It is. And that's what we love about this, getting to explore all these different areas of science and hopefully giving you a bit of a shortcut to, well, understanding what's going on in the world of research without having to read through all those long, complicated papers.
Right, exactly. So without further ado, why don't we jump right in?
Yeah, let's do it. Okay, so let's start with something, well, pretty mind-blowing. Ultra-high energy cosmic
The
rays.
most energetic particles ever observed,
Exactly.
and probably coming from galaxies far, far away. It's incredible to think about, right?
It is, and the Pierre Auger Observatory, which is the world's largest facility for researching these cosmic rays, has been gathering data for over 15 years now.
Gathering data on these particles smashing into Earth's atmosphere.
Yeah, and creating these huge air showers.
Cascades of secondary particles,
Right.
and even producing a faint fluorescent light.
Oh, wow, so you can actually see them.
Well, sort of. It's more like a faint glow that scientists can detect with special telescopes. But the challenge has been to figure out the mass of the original particle, that primary particle, by looking at that maximum fluorescent light.
Okay, I see.
The problem is these telescopes can only work when it's a clear night and there's no moon.
Ah, right, because the moon's light would interfere. So that really limits how much data you can collect.
Yeah, it does. But here's where things get really interesting. Dr. Jonas Klambitsa from FAU, that's Friedrich Alexander University Erlangen-Nuremberg, he's been using AI to tackle this problem.
AI, artificial intelligence.
Exactly. Or to be more precise, machine learning. And he's managed to analyze data from the surface detectors of 60,000 particle showers.
Wow, 60,000.
Yeah, an incredible amount of data that would have been basically impossible to analyze before.
So how does this AI actually work? Like, how does it figure out the mass of these cosmic rays?
Well, they trained the AI using simulations of these particle showers. They basically fed it tons of data about how different types of particles would interact with the atmosphere and create those patterns of secondary particles on the ground. You know, what kind of fingerprint they'd leave behind.
Ah, so the AI learned to recognize these patterns and connect them back to the original cosmic ray.
Exactly. And the results are really interesting. It seems the most energetic particles hitting Earth are most likely heavier nuclei. You know, like nitrogen or iron atoms, not just single protons.
Oh, so not just the simplest particles.
No, and it makes sense, you know, when you think about it. A heavier nucleus smashing into the atmosphere will create a much more complex and wider cascade of particles, and that maximum fluorescent light will appear further down in the atmosphere.
I see. So the AI is basically able to decipher this really complex data and tell us what kind of particles started the whole cascade.
Yeah, that's right. It's able to see patterns that we as humans just wouldn't be able to pick out.
And that's just amazing. I mean, Dr. Blambitza said that without this AI, it would have taken something like 150 years of telescope observations to get the same results.
150 years. That just shows you how powerful this technology can be.
It's incredible. And I think it's something that our listeners will find really fascinating, this idea of AI helping us to unlock the secrets of the universe. So that was a great start. What's next on our cosmic adventure?
Well, how about we move from the incredibly energetic to the incredibly mysterious? We're talking dark energy, that mysterious force that's thought to be driving the accelerated expansion of the universe.
Yeah, dark energy, one of the biggest puzzles in physics.
It really is. And our current cosmological model, the way we understand the universe, basically assumes that dark energy is this constant force. Always there, always the same strength.
Okay.
But some new findings are suggesting it might not be that straightforward.
Really? So what are these findings?
Well, they come from the Dark Energy Spectroscopic Instrument, DESI for short, which is this amazing instrument at Kitt Peak National Observatory.
What does it do?
Well, it's basically a cosmic surveyor. It can observe thousands of galaxies and quasars at the same time, mapping out the universe in incredible detail.
And the goal is to trace the expansion of the universe over time.
Exactly. And here's the thing. The early data from DESI, when it's combined with other measurements, well, it hints that the influence of dark energy might be actually changing over time.
Changing, you mean it's not constant?
Yeah, that's what it looks like. The data suggests that the expansion of the universe might have been accelerating even faster around 7 billion years ago.
Wow, so dark energy was even stronger in the past.
That's what the data suggests, but we have to be careful. It's still early days. As Arnaud de Mattia said, there's absolutely not certainty about this yet.
Right, it's just a hint, a tantalizing clue.
Exactly, but a very exciting one. Alexi Leothod-Harmet, who's a spokesperson for the DESI collaboration, she called it deeply intriguing.
Yeah, I can see why. I mean, if this turns out to be true, it would be a huge discovery.
It would. It could change our entire understanding of how the universe has evolved and will continue to evolve.
It's like we're on the brink of a major breakthrough.
It does feel like that, doesn't it? And the good news is we're going to get much more data in the next few years, not just from DESI, but also from the Euclid Space Telescope, the Nancy Grace Roman Space Telescope, and the Vera Rubin Observatory.
So lots of exciting developments on the horizon.
Yeah, we're at an interesting inflection point, as Joshua Freeman put it.
I like that. An inflection point. It really captures the sense that things are about to change, that our understanding of the universe is about to take a significant leap forward.
It does, and it could lead to a real revolution, as Etienne Burton has said, on the level of the discovery of the accelerated expansion itself, which won the Nobel Prize. He even said it might require us to rewrite our entire cosmological model.
So you, our listeners out there, think about that for a moment. The very foundation of how we understand the universe might be about to shift. That's pretty profound stuff. But let's shift gears now. We've talked about the cosmos. Let's come back down to Earth, or at least to something a bit more familiar, dogs.
Man's best friend.
And they have these incredible noses, right? Their sense of smell is just phenomenal.
It really is. It's so much more powerful than ours. And now a team from Bar-Ilan University has developed a way to actually see what's happening in a dog's brain when they smell something.
They can actually see inside the dog's brain.
Well, not literally see the brain itself, but they can see the brain activity. They've developed this optical sensor that can detect neural activity in real time.
Wow, that sounds incredible. So how does it work?
It uses lasers and a high-resolution camera to capture changes in blood flow in different areas of the brain. Specifically, they're focusing on the olfactory bulb, hippocampus, and amygdala, which are the areas involved in processing smells.
So they can actually see which parts of the brain light up when the dog smells something.
Yeah, exactly. And they tested it with 4 different dog breeds, exposing them to 4 different scents: garlic, menthol, alcohol, and even marijuana.
Marijuana. That's an interesting choice.
It is. I guess they wanted to see if the dogs reacted differently to something, well, illegal. But the most important finding from the study was that the amygdala, which is the part of the brain associated with emotions and memory, plays a really important role in how dogs differentiate between smells.
So it's not just about detecting the scent itself, but also about the emotional and memory associations that come with it.
Yeah, it seems that way. Professor Zev Zalewski, who led the research, said that their new method lets them see that the amygdala is crucial for how dogs perceive smells. He even said they hope to develop a device that can help us truly understand how dogs experience the world through their noses.
Wow, that would be amazing. To be able to tap into that incredible sense of smell and see the world as a dog does. And the technique itself is pretty incredible, too. Using lasers to remotely monitor brain activity. It's much less invasive than traditional methods like fMRI or EEG.
Absolutely. And it allows them to study dogs in a more natural setting. They don't have to be confined to a scanner or sedated.
So where could this lead? What are some of the potential applications of this technology?
Well, you could think about enhancing scent detection for things like finding illegal drugs or explosives, or maybe even training dogs to sniff out diseases like cancer in the early stages.
Oh yeah, I've heard about dogs being able to detect cancer. That's amazing.
It is, and this technology could make those abilities even more accurate and reliable, and maybe even make it possible to bypass the need for expensive training for certain scent-related tasks.
So for our listeners, especially if you're a dog lover, think about this. We're on the verge of being able to understand the sensory world of dogs in ways we never thought possible. And that's pretty exciting, I think. Okay, moving on. Let's take a little detour into science fiction, shall we? We're talking Dyson spheres and ring worlds, those massive structures built around stars.
Truly the stuff of imagination.
Right. But the problem is, they've always seemed pretty impossible from a physics standpoint. Like a solid shell around a star would just be gravitationally unstable.
Yeah, any little perturbation and the whole thing would just tear itself apart.
Exactly. But Colin McInnes from the University of Glasgow has been looking at this, and he's found some really interesting results. He's shown that certain configurations of these megastructures, especially near a binary star system, could actually be stable.
Really? Stable?
Stable. That he was actually inspired by Larry Niven's Ringworld series, as well as the original concept of a Dyson sphere, which was proposed by Freeman Dyson back in 1960.
A Dyson sphere is basically a shell that completely encloses a star, capturing all of its energy.
Right. And McInnes realized that if you have a binary star system with 2 stars orbiting each other, you can create stable equilibrium points for these structures, kind of like Lagrange points.
Lagrange points are those points in space where the gravitational forces of 2 massive bodies balance out. So you can have an object, like a satellite, sit there without being pulled in one direction or the other.
Exactly. And McInnes found that similar points exist for rings and spheres in a binary system. So a ring world or a Dyson sphere could actually be stable if it's positioned just right.
That's amazing. So maybe those massive structures aren't just science fiction after all.
Maybe not. And this has some interesting implications for the search for extraterrestrial intelligence, too.
How so?
Well, if we know where these structures could be stable, it could help us narrow down our search for technosignature signs of advanced civilizations. Like if we see a star with a strange infrared excess, it could be because it's surrounded by a Dyson sphere.
Makes sense. So instead of looking everywhere, we can focus on those systems where these megastructures would be most likely to exist.
Yeah, exactly. So, it's fun to think about, are there advanced civilizations out there building these incredible structures? We don't know yet, but the possibility is definitely there. Okay, let's come back to Earth again for our next topic. This is a bit more down to earth, but still pretty mind-blowing. A team of physicists is proposing a way to generate electricity using the Earth's rotation.
From the Earth's rotation. That sounds wild.
It does, doesn't it? But they've actually done an experiment. They built a cylinder out of a material called manganese zinc ferrite, and they oriented it so that it's perpendicular to both the Earth's rotation and its magnetic field.
Okay, I'm following so far. So what happened?
Well, they measured small voltage across the cylinder, only 18 microvolts, but they couldn't explain it by any other means.
So they think it's coming from the Earth's rotation.
That's what they think. They ruled out other possibilities like temperature differences, and they even did control experiments with different orientations of the cylinder, and none of those produced the same voltage.
So it does seem like there's something to this.
Yeah, it's still early days, and the researchers are very cautious. They say the results need to be verified by other teams.
Of course, that's how science works.
Exactly. But if they're right, it means we might be able to tap into this incredible source of energy, the Earth's rotation. Think about how much energy that is. It's constantly spinning.
It's a huge amount of energy. It would be a game changer if we could figure out how to harness it.
It would be. So for our listeners, I want you to think about this. What if we could power our cities, our homes, everything, using the energy of the Earth itself? That's the kind of future that this research could lead to. Okay, last but not least, let's talk about one of the biggest mysteries in physics. Quantum gravity. That's the quest to unify general relativity, which explains gravity, with quantum mechanics, which explains the behavior of particles at the subatomic level.
The holy grail of physics.
It is. And as it turns out, neutrinos, those tiny, almost invisible particles, might hold some clues to this unified theory.
Neutrinos are fascinating. They're everywhere, but they interact so weakly with matter that they're incredibly difficult to detect.
Right, they're like ghosts passing right through us. But we do have detectors that can pick them up, like the KM3-NET-T, the Kilometer Cube Neutrino Telescope, which is located deep underwater in the Mediterranean Sea.
Why underwater?
Well, water helps to shield the detector from other particles that could interfere with the measurements. And when a neutrino does interact with the water, it creates a flash of light called Cherenkov radiation, which the detectors can pick up.
So looking for these tiny flashes of light to tell them that a neutrino has passed through.
Exactly. And here's where it gets really interesting. Neutrinos can actually change their flavor as they travel. There are 3 types of neutrinos: electron neutrinos, muon neutrinos, and tau neutrinos. And they can oscillate between these flavors.
Oscillate, you mean change back and forth?
Yeah, that's right. It's a quantum mechanical phenomenon, and it relies on this property called coherence. Basically, a neutrino exists in a superposition of these different mass states, and coherence keeps that superposition stable.
Okay, so coherence is essential for these oscillations to happen.
It is. But some theories of quantum gravity suggest that interactions at the quantum gravity level could cause decoherence. That would disrupt the superposition and suppress the oscillations.
So if we could see this decoherence in neutrinos, it would be a sign that quantum gravity is having an effect.
Exactly. So a team led by Nadja Lessing used the KM3-Netorka detector to look for signs of this decoherence, and they didn't find any.
So no evidence of quantum gravity?
Not yet. But it's not a failure. It actually allows them to set new limits on the strength of these potential quantum gravity effects. They're saying if quantum gravity is causing decoherence, it's doing so at a level that's below our current ability to detect.
I see. So it's helping to narrow down the possibilities.
Yeah, it's like eliminating suspects in a mystery. And Lessing herself said that finding this neutrino decoherence would be a big thing for the field. It would be a major clue to how quantum gravity actually works.
So the search continues.
It does, and I think that's a great place to end our deep dive. We've covered so much ground today, from cosmic rays to dark energy, from dog brains to Dyson spheres, from Earth's rotation to the very fabric of reality itself. It's been quite a journey.
It has, and hopefully our listeners have enjoyed the ride.
I hope so too. And remember, the goal of this deep dive was to give you the taste of the incredible discoveries that are happening in the world of science, to pique your curiosity and inspire you to learn more.
And if you found something particularly interesting, we encourage you to dig deeper. Check out the original research papers or explore related topics. There's a whole universe of knowledge out there waiting to be discovered.
Exactly. And who knows what amazing breakthroughs await us in the future. As we continue to explore the universe and unravel its mysteries, we're bound to find things that will surprise us, challenge us, and ultimately change the way we understand the world around us.
And perhaps even inspire us to build those Dyson spheres ourselves one day.
One can dream, right? Thanks for listening, everyone, and we'll see you next week for another deep dive into the world of science.
See you then.